Okay, class. I had a student in one of my classes ask a question related to homework, and I actually realized this would be good for my micro and my macroeconomics class. So there were three problems that the student asked about. One was a question of using a table of prices and quantity supplied and quantity demanded to address the discrete answer of what's the producer surplus and the consumer surplus. So I'm going to show you an example of how to do that. The next problem was related to a question on calculating price elasticities of demand. Um, this one was asking for the average change, but to use the midpoint formula. I think that might have thrown someone off, so it's actually not that challenging. And then the third was one of the doing data or doing the news problems related to measuring percentage change. I'm going to show you how to measure any percentage change, but then we'll also talk just for that data set, since it was using price index data, which is normalized to 100, how to solve that. So this should be a short and quick video. So first up, I want to show you the data I'm using. I chose easy data for all of you to replicate. So we've got prices going in $5 increments from 0, 5, 10, 15, 20. And we've got the quantities supplied and quantities demanded. Of course, when the price is low, the quantity demanded is high. So quantity demanded is 40. And the data is symmetrical. So when the price is high, the quantity demanded is 0, and the quantity supplied is 40. So what we're going to do is we could graph out a chart of what this data looks like. And I'll just do that very quickly. So we end up with the demand curve that goes from 0 to 40. And we end up with a supply curve that goes from 0 to 40. Okay. Okay, so we end up with 40 right here. Just show you, this is what that supply and demand curve would look like. Now we want to find the equilibrium. So to find the equilibrium on the data, we look for the point where one price equals the same quantity supplied and quantity demanded. In the graph, we look where the quantity supplied and demanded intersect, and we will get the same point. So we find out the equilibrium price is going to be 10, and the equilibrium quantity is going to be 20. I'll just circle that in my data as well. So recall that the area above the price line and below the demand curve ends up being our consumer surplus region. And so if we're thinking about that from our table, what we're learning is that there are people who were benefiting from getting a lower price than they would have paid otherwise. So there were people that at least at $15 who were willing to buy quantities. And so that represents our area of consumer surplus. And for producers, there were producers who would have been willing to sell at a price less than $10. And so that represents our producer surplus. Graphically, the consumer surplus is the area above the price line and below the demand curve. And producer surplus is the area below the price line and above the supply curve. And I've just circled the quantities supplied and quantities demanded of people who, in this case, in the demand curve, they were willing to pay $15, but they got to get a cheaper price. And that's because of something called the law of one price. In a perfectly competitive market, one price prevails. And so even though there were people willing to pay a higher price, they got to benefit by having this lower price. Same thing here. There were people willing to sell at a lower price, but they got to benefit from the higher price. And so to calculate that, you just need to figure out how many of those people are. So in the case of the consumer surplus, we can see that there were people willing to pay $5 more, the difference between 15 and 10. So $5 more times 10 items would have been sold. And so that means your consumer surplus is 50. Okay. And in the case of our producer surplus, there would have been people willing to pay $5 more, and there would have been 10 of those items sold at that price, which would have been 50 as well. Okay, so let's see. So we end up with a calculated consumer surplus of 50. The $5 that they would have been willing to pay more, 10 minus the 15, or 15 minus the 10, $5 more times 10 units sold would have been sold at that price. So those people benefited by $50. The producer surplus, there would have been 10 people willing to supply units, or 10 units supplied at a price of $5. And so they ended up getting $5 more. The difference between 10 and 5 times that 10, so that's another $50. This differs than the geometric solution, which the geometric solution would have had consumer surplus equal to the difference between the prices, which is 20 minus 10, which is 10 times 20. So the base of this triangle times its height. So 10 times 20, which is 200, divided in half, because that's the area of a triangle. So that would have been 10 times 20 is 200, divided in half is $100. Same thing would have been true. The reason it's different is because in our problem, we're finding that the discrete solution is that no one wanted anything here, and there was no ability to get price variability between 20 and 15. And so we're only really calculating, or 20 and 15, so, or 20 and 15. So we're only calculating from here to here, this little triangle. And we're saying that we have no data that sales occurred up here, and so the graph really doesn't extend all the way to the boundary. This is the difference in economics between having a discrete problem and then having a continuous problem. Discrete problems require discrete solutions. What I mean by discrete is, some things can be sold just one at a time. 1 egg, 2 eggs, 3 eggs. In fact, eggs normally are sold 6, a dozen, 18, 2 dozen, 3 dozen, 5 dozen. What would it mean to go out and say, I'm going to buy 1.5 eggs? You can't actually do it. Now, a lot of times what economists do is they assume that products are infinitely divisible and that people can keep buying all the way up to X price or X quantity. And keep selling, and they can sell in a continuous fashion. One of the reasons we do that, even though that might not be the way the real world works for some items, is because the answer gets us close enough, right? And so we can imagine that there probably were people willing to pay higher, but there was no one willing to pay 20. But there might have been some people, if we had more data, willing to pay $16 or $17. Now, one more thing, the problem in your homework is a little more complex. It involves calculating the spread between each point, so the table's a little bit more dense. And what you would have to do is, for every $5 increment, there's a couple of ways to go about it, but the way I think about it is the price changes by $5, 10 people. If the price changed by $5 again, and there had been some positive number here, then we would say that these people are already included in the calculation, so we need the new people added. So we want to make sure that we're only calculating people once. So, for example, if we talk about here, at a price of $5, there's 10 people. At a price of 10, there's only 10 more. At a price of 15, there's 10 more. At a price of 20, there's 10 more people willing to sell. And so if we're calculating this whole area of people willing to sell, we do 5 times 10, $5 more times 10 new people, $5 more times 10 new people. We're looking at the difference between each point. So just remember that when you're doing your calculation, and you'll be well served. So the next problem was looking at midpoint slope formula and calculating the average change. And the problem, I'll just use the actual problem on this one, something like your initial quantity was equal to 7,450. And the problem said, now you subtracted 1,600. So if that's true, then your quantity at second point is going to be 7,450 minus the 1,600. I'll just show you what I wrote. I had a little typo there. So quantity 1 is 7,450. Quantity 2 is 7,450 minus 1,600. We solve for that, and we get 5,850. Now, if you just calculate the percentage change using a formula that you'd know from math, you'd get the wrong answer, because the question actually said use the midpoint slope formula. and to calculate that quantity change. And we know that the midpoint slope formula says the percentage change in quantity demanded or supplied is going to be equal to Q2 minus Q1 over the average of Q2 plus Q1 divided by 2. And so we want to calculate this, and so we can insert our numbers in. And we're going to assume in this one we wanted a positive number, so we could do it differently. But anyway, we'd end up with 7450. Doesn't really make a difference which direction, it just changes the positive or negative sign. Minus 5850. That's going to be equal to, we already know that, 1600 over the average of 7450 plus 5850 divided by 2, which is just the average. So this is where I'm at on this problem. So then we solve some more and we get 1600. And you, depending where you put it, front or back, would have gotten plus or minus. For this problem, it really doesn't make a difference. Over the average 7450 plus 5850 divide by 2. There you go. Now I'm going to pull out a calculator to solve this average to kind of cut down on some time. And so I get plus or minus 1600 over 6650. And that's going to be equal to 0.2406. And we're going to multiply it by 100, turn it into a percentage, and we end up with 24.06%. If my math is right. But you're going to use that midpoint formula, and it could be plus or minus. Depends on the way the problem's written, whether you want it to be plus or minus, a positive or a negative. But I think whatever happened when you were calculating that, you probably got like 21 or 28, depends how you calculate it, and how wry you went. The reason was you were using the method I'm going to show next for just a generic percentage change, which is you're using some variety of percentage change of anything is normally equal to the new value minus the old value divided by the old value. I call this the no method times 100. And this is a general formula for percentage change. There's other versions of this. This is the one I used. And if you would have inserted that in, you would have gotten the wrong answer because they asked for the midpoint slope formula version of a percentage change, not for the normal calculation. And you would have ended up with 7450 minus, that's your old value. And we'll leave it that way. It just reverses it. 5850 over 5850 times 100. I'll actually do it the right way. Which would equal 27.35%. Let's do it the right way. 5850. 4. And depending how you organize the problem, and I'd have to go back and read it to see the structure of the problem. I didn't write that down in my notes. You would have ended up with your new minus old or your old minus new, 7450. And unlike the problem above, it would have made a difference because of the way you were doing it. And so you would have ended up with 21% or 27%, but the correct answer is 24%. This also helps with the third one problem that student have, which is how to measure the percentage change. And you were there in that one looking at tables, and the table would have given you like 100 for the beginning value on the graph to 134. Well, we can do that new minus old percentage change in, I think that might have been a consumer price index, but I don't know. I don't remember what it was. Would have been equal to the new value 134 minus the old divided by the old times 100. And if we solve, we would get 34%. But the nice thing about data that's put in price index form is that it's been normalized to a base year of 100. And so what that means is you just take the 100, if you're comparing to the 100, and you just go 100 to 134 is a 34% change. 100 to 116 is a 16% change. So you can actually just look at the data to infer the answer, but if you need to calculate, you can calculate it like that. Anyway, those are the solutions to some of the problems or problems like that. If you have any problems with this, let me know. I can always do more videos. This is the first time someone's asked me a problem where I felt doing the video would be simpler than typing out a solution. So if you have homework problems, as always, just let me know and I can do another video. Thank you.